Right, we have another question. Um, this is example 3. Example 3 still on acceleration due to gravity or gravitational field intensity. It says the radius of the moon is 1/4 and its mass is 1/81st. Is 1/81st that on the Earth. Full stop. If the acceleration due to gravity on the surface of the Earth is 9.8 meters per second square, what is its value on the moon's surface? Alright, so let's look at that quickly. First thing that was given to us is the radius of the moon being 1/4. So we say radius of the moon is 1/4 of the radius of the Earth. Okay, that means that rm is 1/4 times re. So off changes to what? Multiplication. And that rm is equals to 1 times re is re over 4. If I cross multiply, re will be equals to 4 times rm. And I'm having that re is equals to 4 rm. You can call this one equation 1. You can call this equation 1. Okay? So the radius of the Earth now becomes 4 times the radius of the moon. If the radius of the moon is 1/4 the radius of the Earth, when we solve after the arithmetics, we arrived at the radius of the Earth being 4 times the radius of the moon. Okay, so we take note of that. Then we continue. It says, and the mass of the moon is 1/81st that on the Earth. So we say mass of the moon is equals to 1/81st of the mass of the Earth. That means that mass of the moon is equals to 1/81 times me, which is that the mass of the moon will be equals to me over 81. Okay, right? And if I cross multiply, me will be equals to 81 times m1 mm. That means that the mass of the Earth here will be 81 times the mass of the moon. Therefore, the mass of the Earth is 81 mm, which I can call this equation 2. Okay, so we arrived at that. First, we obtained that the radius of the Earth is 4 times the radius of the moon. And then secondly, we obtained that the mass of the Earth is 81 times the mass of the moon. Okay, so it says initially we are told that the mass of the moon is 1/81 of the mass of the Earth. Now if it is 1/81st the mass of the Earth, we then have to make me subject of formula. That is, mm will be equals to 1/81 times me. And when I multiply 1 times me is what? Is me over 81. Now, if I cross multiply this, 81 times gives you 81 mm. That the mass of the Earth will be 81 times the mass of the moon. So me is equals to 81 mm, right? Then it goes on to say, says if the acceleration due to gravity on the surface of the Earth is 9.8 meters per second square, what is its value on the moon's surface? So we are told that the acceleration due to gravity on the surface of the Earth is 9.8. So you indicate that GE is 9.8 meters per second square. Now they said find the acceleration due to gravity on the moon's surface. It is unknown. So we also go back again. Remember that GE is G capital ME over RE square. Okay, that is the formula for the gravitational field intensity, or my acceleration due to gravity. Now, acceleration due to gravity on the Earth's surface is the gravitational constant times the mass of the Earth divided by the radius of the Earth raised to the power of 2. So if I substitute the values here, in place of this, in place of GE, I write 9.8. Okay, and then in place of ME, I will also write 81 mm. And then in place of the radius of the Earth, I write 4 rm. and this now will change to, this then changes to 9. You have 9.8, you have 9.8 is equals to capital G times the mass of the earth there is 81 mm. That is 81 mm over the radius of the earth. Radius of the earth is 4 rm. So that is 4 rm, all raised to the power of 2, because there is a power 2 here. Okay, so in place of the radius of the earth, I write 4 rm. I substitute it there, and in place of the mass of the earth, I write 81 mm, which is this. So I'm having that 9.8 is equals to 81 mmg over 4 raised to power 2 is 16 rm square. Okay, so if I cross multiply, I'll have 81 mmg equals to 9.8 times 16 rm square. Okay, so 9.8 times 16 will give me 9. Okay, so this now will be equal to, we have 156.8 rm square. Okay, is equal to 81 mmg. Okay, so if I then make G subject of formula, remember when I multiplied these two, I had 156.8. I make G subject of formula, after G is equals to 156.8 rm square over 81 mm. Okay, which I can call this one equation 3. I can call this equation 3. So I have my gravitational constant capital G as 156.8 rm square over 81 mm. Okay, now also recall that the acceleration to gravity on the moon is capital G mm over rm square. Okay, so if the acceleration to gravity on the earth's surface is given by the formula capital G me over r e square, then the acceleration to gravity on the moon will be capital G mm over rm square. Alright, which I can make capital G the subject of formula there, and I'll be having, so we have that the acceleration to gravity on the moon surface is capital G mm over rm square. I can call that one equation 4. So what do you think? If I substitute equation 3 into equation 4, in place of this capital G, I will write 156.8 rm square over 81 mm. So I will substitute that quickly, and I'll be having, say, substitute equation 3 into equation 4, and then I'll be having Gm equals to 156.8 rm square over 81 mm multiplied by mm divided by rm all square. Okay, so we discover that this will eliminate this, and likewise then I'll be having something like 156.8 rm square over 81 multiplied by 1 over rm square. Okay, then you observe that this rm square will also eliminate rm square, and so my answer then becomes, if you check 156.8 divided by 81, it gives you 1.936 meters per second square, which is approximately 1.94 meters per second square to 2 decimal places. Okay, so I have my acceleration due to gravity on the moon surface. Acceleration to gravity on the moon surface is 1.94 meters per second square to 2 decimal places. And we also obtained from this formula, we saw how we made the gravitational constant subject of formula there, and we input the value inside there. Then when we multiplied it with the mass of the moon over here, you see that the mass of the moon will eliminate this mass of the moon here. Both of them will cancel out by elimination, and then we arrived at 156.8 divided by 81, and then you multiply this with rm square as well. What then happens if you adjust this one by the side? Adjust this by the side, you're having 1 over rm square. So this will eliminate this, and so you'll be having 156.8 divided by 81, which gives you 1.936. With your scientific calculator, when you approximate 6 to 4, that is 1.94 meters per second square to 2 decimal places. Alright, so this is the acceleration to gravity on the moon surface, and we should also know that the acceleration to gravity on the earth's surface is 9.8 meters per second square. It's a constant value, but that on the moon surface is 1.94 meters per second square. Alright, thank you.